Hi everyone! Today I'm going to be explaining what the law of sines is and how it can be used to solve different kinds of problems. The law of sines is a theorem that states that the sides of any triangle are proportional to the sines of their opposite angles. Just like a lot of mathematical concepts, and especially in a class like trigonometry, it is helpful to use a picture to better visualize what this actually means. And so looking at this triangle that I've drawn on the right of the slide, what the law of sines is actually saying is that the sine of angle A over side A is equal to the sine of angle B over side B, which is equal to the sine of angle C over side C. And that's the equation that's just written on the bottom of this slide. This mathematical relationship is extremely helpful when it comes to solving a triangle, which basically just means solving for all of the angles and side lengths of a triangle. And the law of sines can be used when given either an angle, its opposite side, and one other side, or when given two angles and one of their opposite side lengths. And triangles are used in many fields of study like engineering, chemistry, architecture, physics, and a bunch of other things. Using the law of sines to solve for various components of the triangle is very helpful for problems within these fields of study. Let's go through a quick example of how to solve a triangle using the law of sines. For this problem, we are given a triangle with sides A is equal to 18, B is equal to 30, and angle A is equal to 25 degrees. The best way to begin these problems is by drawing a triangle and filling out what we know and what we need to find. This drawing below, that's on the left-hand side of your screen, shows that we need to solve for the angles B and C and side C. Next, we can set up the law of sines relationship using the given information. After this is set up, we can use this relationship to solve for angle B since we already know what side B is. In order to do this, we can do some algebra to get B by itself since that is our unknown. Once sine of B is by itself, the way to get just B by itself is taking the arcsine or inverse sine of each side. Once that is plugged into the calculator, we get angle B to be equal to 44.78 degrees, which we can just round to 44.8 degrees for this problem. Now, a fact that can be helpful for these or any kind of problem that includes triangles is that the angles of a triangle have to add up to 180 degrees. Using this fact, we can easily solve for the last angle, which is angle C, by subtracting angles A and B from 180. This gives us a value of 110.2 degrees for angle C. Now, we just need to solve for side C. We can use the law of sines again to solve for this side. Again, algebra can be done to get C by itself, and then once plugged into a calculator, we get that C is equal to 40. Now that we have all these pieces, we have completely solved the triangle. The last problem that we did was pretty simple mathematically once we understood and set up the law of sines. However, there's technically one more thing that we need to think about when we're doing these kind of problems. If we look at the unit circle that I've put on this slide, you can see that the value of sine, which is just the y value at any of the angles, is positive for the entire upper half. For example, if we look at the angles 30 degrees and 150 degrees, they both have the same sine value of 1/2. However, if we plugged arcsine of 1/2 into the calculator, it would only give you the value of 30 degrees. Because of this ambiguity, we should always check whether or not there are more possibilities than what the calculator gives us. This ambiguity gives us three kinds of problems: some that have no possible triangles, some with one possible triangle, and some with two. These are all of the cases for each kind of problem that can arise with the law of sines. These cases contain a new component of the triangle, which is the height, which is represented by the letter H in each of these pictures. This usually isn't given in the problems, but it can easily be solved for using one of the given sines and angles and your favorite trig function. If your given side A is greater than side B, or if side A is greater than the height of your triangle, there's only one possible triangle that you can get. If side A is less than B and greater than H, there are two possible triangles you can get. Finally, if side A is less than H, and if you have an obtuse triangle and A is less than B, there's no possible triangles. These rules are kind of hard to notice when first looking at the problem and what is given, so to be safe, we should always just check for two different triangles. Now let's look at one of these problems when there are two possible triangles. For this example, we are given angle A equals 38 degrees, side A equals 40, and side B equals 52. Just like the last problem, we'll start with setting up the law of sines with our given values. Now let's first solve for angle B just like we did on the last problem, by getting it by itself using algebra. This step is listed at the top of the slide, and once it's plugged into the calculator, we get a value of 53.2 degrees for angle B. Now just like we saw on the unit circle, there is another angle that could also fit in this triangle. We can solve for this other angle by subtracting our found angle from 180. Now, this will give us a second possible angle of 126.8 degrees. Now, since there are two possible values for the angle B, there are two possible triangles. To be complete, we need to solve for the C values for both of these cases. The process is the same as the first example that we did, we just have to do it twice. First, the angle C is solved for by subtracting angles A and B from 180. Then, that angle is used with our law of sines to solve for side C. Below, I've drawn each triangle with their solved values so that we can compare them. As you can see, they share some angle values such as A and side lengths such as A and B, but are still fundamentally different. Usually a problem will specify whether it is necessary to solve for this second triangle, but is good practice to always check for it when doing problems with the law of sines. Overall, the law of sines is a very useful relationship when it comes to solving triangles. The ambiguity can be a little confusing and easy to miss, but as long as you always check for that second triangle by subtracting your found value for angle B from 180, you should be good. These are the sources that I used to research this topic, and I would recommend taking a look at them to further understand this concept. Thank you for watching.